Good morning, everyone. Hope all is well. Let's see. Good morning. Think we all are in here. Okay, cool. All right, so hope everybody's good. Everybody's great. Ready to get the weekend started. Um, we'll probably just do one section today, just off the strength of you guys got chapter 2 work to do. Let me Man, if I signed into my old school's email, I'm holding on for a long time. I don't, that wouldn't be my issue. But yep. So yeah, we'll just do one section today. And like I said, we have a due date for chapter 2, so take advantage of the time. I think we got 10/17 for everything chapter 2 related. So make sure you get it in before that time.
You weren't willing to push it to 1020, that even number looking pretty good.
Didn't you ask me that before? Was that you? Is that what I
Yes.
was thinking about that, wasn't I? I hadn't thought twice about it, man. I just like I owe Mr. Williams that video. I hadn't even thought about it. like the video things got so hectic, I didn't get a chance to do it. That 2020, that 1020 day, I completely forgot about that. Yeah, shoot me an email to remind me to do that. I can do that. I don't have a problem with that. But I'm pretty sure I'm gonna forget. So yeah, shoot me that email to remind me to shoot that date, the 1020, and I'll make that happen. But yeah, Mr. Williams, I forgot about you, man. I ain't trying, but I'm trying not to destroy a happy home either. So I'm gonna get it to you though.
We're good, man. We're good.
All right. So let's look at 3-1 today, and then call it a day. Unless anyone objects, we'd rather go ahead on and we can get going all the way to chapter 4 if you like. I mean, I'm good with it. Let's see. So 3-1 quadratic functions. Starting off looking at this parabola. So we did focus more so on linear equations up to this point. So now we're looking at quadratic functions or linear functions. We're looking at quadratic functions in chapter 3, at least starting off that way. When you're talking about your quadratic, you're always going to get a parabola. You can either open up, which is concave up, or open down, which is concave down. So that's the mathematical way of saying it, versus saying open up, they say concave up. Instead of saying open down, it says concave down. So whenever you're testing, when you get into calculus, for those who are going to calculus, if you're trying to test your concavity, that's what you're talking about, whether it opens up or down, stuff like that. So if it concaves up, you're going to have a vertex. That is your minimum, your lowest value. Where's my P? And there we go. If it opens up, your vertex is the lowest value. So that's your minimum. If it opens down, your vertex is your highest value, which is your max. Coordinates of your vertex is going to be called HK, just like the coordinates of our center of our circle is HK. All right, scrolling up. So standard form of a quadratic equation, a times x minus h squared plus k. Of course, a cannot be equal to 0, or that will cancel out, a whole bunch of stuff, right? But if a is greater than 0, in other words, a is positive, then your parabola concaves up, of course, concave up. If it's less than 0, in other words, negative, then concave down. Also notice the coordinates of our vertex is HK, but we have a minus H right here. So you'll always use the opposite sign of H, but you use the regular sign of K. So you'll see that when we actually do an example, because we have this minus sign right here, you use the opposite sign of H, but K, you will use that the regular sign. All right, how far? When we said see the top again, we were right here. Is that what you're talking about? Is that good enough? Oh, you're talking about all the way up top. All right. Good, good. Let me know, let me know. No problem. All right, so let's look at graphing quadratic equations with the equation in standard form. Have a couple of steps here. So the first one, DET, is just determine. So determine your concavity. So in other words, is A positive or negative? So it's not is A positive or negative, but is A. We're talking about letter A. Is A positive or negative? So that's what I'm writing there in that blue. I mean that red box. Is A positive or negative? That will determine your concavity. That's what we're talking about up here. Determine your vertex. Find x-intercepts, if any. Find your y-intercept. So everybody done with that top part?
What does it say in red? Positive or negative?
Is A positive or negative? We're talking about this right here. Just re-emphasizing, you know, when we say determine concavity, what we're talking about. So is the letter A positive or negative? And then for 5, you're going to plot all of those points and then use additional points if necessary. Or as necessary, depends on how accurate you want to be with your graph. All right, can we scroll up? All right, let's look at the first example under these steps. F of x is equal to -2 times x minus 3 squared plus 8. So we have A, not A, but so we have it fit in the form of our general form that we just finished mentioning. So that A times x minus 8 squared plus K. So first step is determine your concavity. A is equal to -2. Since A is negative, that means it opens downward. So it concaves down. 2 is determine your vertex. So notice it's HK. That's our vertex. But we have this negative sign here. So you're going to use the opposite sign for H. That's why I have a 3 here. And then 8, you just use the number that we have. Excuse me. So before we go to step 3, everybody okay with 1 and 2? All right. Find your x-intercept. So remember, for all x-intercepts, y is always 0. And don't forget y and f of x are the same thing. This is just function notation. So we're going to replace that with 0. So 0 equal to -2. Times x minus 3 squared plus 8 is what we have now. And we want to solve for x. First thing we'll do is subtract 8. That'll give us -8 equal to -2 times x minus 3 squared. Divide by -2. And that will give us 4 equal to x minus 3 squared. Now we need to get the square off of x. So we'll take the square root of both sides. And don't forget the square root property. Never take the square root of both sides. Plus or minus has to be involved on that other side that the square and square root didn't cancel. And then that means we'll have plus or minus 2 equal to x minus 3. And we can finish that off by adding 3 to both sides. So we have 3 plus or minus 2. Now, since we can add and subtract 3 and 2 from each other, we can go ahead and do that. 3 plus 2 will give you 5. 3 minus 2 will give you 1. So our 2 x-intercepts will be 5, 0, and 1, 0.
So that number that we just solved for, the 5 and the 1, those were negative. Would those go behind the 0?
No,
Would they
no,
be-
these are actually points. These are ordered pairs. So these
Right.
graph these. Yeah. So remember the way this is set up is x, y. So whatever x is always going to go here, and whatever y is
Okay.
going to go here.
Gotcha.
Yeah, and y was 0. So 0 is always going to be there for y.
Gotcha. Thank you.
Why do you do plus or minus square root 4 instead of just solving the square root of 4?
Because of the square root property. So it says that whenever you have to take the square root of both sides, you have to do plus or minus. That gives an account for both of the situations. So in other words, if I had x squared equal to 25, there are 2 situations in which that can be true, when x is 5 and when x is -5. Because 5 times 5 is 25, -5 times -5 is also 25. So when you take the square root of both sides, it's given an account for the plus and the minus option as far as the answer for x. So whenever you take the square root, you always have to do plus or minus. Hopefully that was what you were actually asking. Yep. 2 times 2 is 4, but -2 times -2 is also 4. Yep. So you have to give an account for that positive and negative occurrence of getting 4. All right. So the next step is to find your y-intercept. So when you're trying to find your y-intercept, you let x be equal to 0. In order to find your x-intercept, you let y be equal to 0. Find your y-intercept, you let x be equal to 0. So we just plug 0 in to the function. for x. So -2 times 0 minus 3 is squared plus 8. -3 squared is 9. -2 times 9 is -18. -18 plus 8 is -10. So the order pair here is going to be 0, -10. So this time x is 0. So that's why 0 goes first when you're looking at your y-intercept. And this negative had nothing to do with the fact that it comes second. It's just that that's why. That's your y. All right. So after you've found those points, graph them, get you a rough sketch of your parabola. All right, we good. Can I scroll up?
I think I'm missing something. Where did the 3, 8 point come from?
That was your vertex. That was all the way step 2. Came from right here. Yep. All right, we good. All right, so if your equation is not in that form, we still can find the vertex. So the form we normally used to seeing is ax squared plus bx plus c. So if it's in that form, you still can use a and b accordingly to find it. Well, it's a and b and c still mean the same thing. You would use a and b in this fashion to find your vertex. -b over 2a would be h. And then you take that result, plug it into your function, and that will give you k. All right, so we're looking at f of x is equal to -x squared minus 2x plus 1. So a is going to be a regardless. If it's positive, it opens up, but if it's negative, it opens down. So we see that it's negative here, so it concaves down. So now let's find the vertex. So once again, x for your vertex, or in other words, h, that's -b over 2a. So negative is a part of the formula. Don't lose a negative. So b is -2. So that's minus or -2, or if you want to say -2, whichever way you want to say it, but -2 in the numerator, then 2 times -1 in your denominator because a is -1. Then that'll be 2 over -2, which is -1 for h. Then to find K, plug it into your function. This is our function right here. Plug -1 into a function. So that's -1 squared minus 2 times -1 plus 1. -1 squared is 1. So that's a -1 plus 2 plus 1. And that'll give us 2. So our vertex is -1, 2. So when it's not in that general form, you have to do a little bit of work to find the vertex, but you know, nothing you guys can't handle, right? All right, scrolling up. So now we go back to our intercepts, find our x-intercept, gonna let y be equal to 0. So that's -x squared minus 2x plus 1 equal to 0. Remember that was f of x. F of x was 0, which is y. So this is not factorable. Somebody said something. Yeah, this is not factorable, so we're gonna have to use our quadratic formula in order to solve for x. Hopefully that was up enough. If not, let me know. All right, scrolling up a little, and of course, let me know if I go up too far. So once again, we cannot factor this equation evenly, so we use the quadratic formula, -b plus or minus square root of b squared minus 4ac over 2a. All right, so a is -1, b is -2, c is +1. Plugging in -2 for b, we got -2 plus or minus square root of -2 squared minus 4 times -1, which is a, times +1, which is c, over 2 times -1, which is a. Under the radical, that simplifies to 4 plus 4. On the outside, that -2 times -2 is +2. Two plus or minus square root of 8 over -2. All right, so we're trying to graph this, so I needed some decimal values or some actual values. So I just went ahead and graphed it. I didn't write it in its most simplest form. I just went ahead and converted it to a decimal. So we got -2.4 and then 0.4. Those are our ordered pairs. Oh, someone says something. Yes, you can use completed square as well. Yep. Mhm. All right, scrolling up some to the next step, which is our our y-intercept. And if we're looking for our y-intercept, we'll let x be equal to 0. We're just going to plug in 0 for x. All right, so plugging 0 into our function, that's negative 0 squared minus 2 times 0 plus 1. So that'll give us 0 minus 0 plus 1, which is just 1. So the order pair there is 0, 1. All right. You just grab those points. Squiggly sign, squiggly sign. Oh, approximate. That means approximately. So in other words, that's a run-on decimal. So it doesn't come out to exactly negative 2.4 or 0.4. I had to round it off. I was like, squiggly line, what? All right, any other questions? So that's, graph those points. That'll give you a rough sketch of your parabola. All right. So these next two statements just reiterate something we already mentioned already, that if A is greater than 0, if A is positive, then you know it concaves up. So that means you'll have a minimum at your vertex. Remember we said that you can use this relationship to find the coordinates of your vertex. And then if A is less than 0, then your parabola has a maximum because it opens down, concave down. You have a maximum at your vertex. Just another way of saying it, another way of emphasizing the relationship. All right, so here we have f of x is equal to negative 3x squared plus 6x minus 13. Ask us to determine whether it has a minimum or maximum value. Scroll up, you okay with that? So the first one, it opens down because A is equal to -3. That means we have a maximum value, have a peak. All right. B asks us to find the vertex. So when it says find the minimum or the maximum, they're talking about the vertex. So find the vertex. Everyone still holding on to that last statement? We okay? All right. So we know A is -3, B is 6. So we want to find H, the X coordinate of your, or the X component of your vertex. That's -B over 2A. So plug in 6, plug in -3. -6 over 2 times -3, that'd be -6 over -6, which is equal to +1. Scroll up on A. So once you find H, you take 1, plug it into your function. So where's my end of this? Wait a second. There we go. So that's 3 times 1 squared, -3 times 1 squared plus 6 times 1 minus 13. So -3 times 1 squared is just -3. 6 times 1 is 6 minus 13. That reduces to -10. You say go faster? Do I need to scroll down or are we okay right here? Scroll down some? Okay. So let me see what we do it like that. How are we looking with A? Can we scroll up on A? Very good. Okay, cool. So that's the end of B. We'll pause right here. But we have our coordinates now for our vertex as 1, -10. All right, so I think C is the last part of this problem. So then it says identify the domain and range. All right, so don't look at a green circle yet. We'll talk about it in a second. I don't know why I wrote it so close. Probably just talking to somebody about it. But we're going to identify the domain and range. So we know we have our parabola concave down. We have a maximum. So, but the first thing we're looking at is our domain. Domain is our x values from left to right. So it always, when you write it, we talk about left to right. And in the parabola, whether it's concave up or concave down, will always continue to get wider and wider and wider to infinity. So domain is always going to be negative infinity to infinity for these parabolas. Okay, so that's always going to be the case. If you have a parabola, the domain does not change. It's always going to be negative infinity to positive infinity. All right. Now your range is what can change. And of course, that will be determined by the fact, by whatever your vertex is and whether it concave up or concave down. So this concaves down, and we always write our lower value first. That's why I say for your domain is left to right. For your range is down to up. So our lowest value, when we look at our parabola here, our lowest value is negative infinity. So we're going from negative infinity up to negative 10. And don't forget, we're looking at the y component. So we're not looking at the 1 in our vertex. We're looking at the negative 10. So that's why our range is from negative infinity up to negative 10. And I'll use a bracket on that because negative 10 is a part of your range. And so in that green circle, notice I put up there, if it opened upward, that means we have a minimum and our lowest value will be negative 10. So we go negative 10 up. So that's why you will have negative 10 to infinity. So that's the difference between having your parabola opening downward versus opening upward. If it's opening downward, that means you're going to start with negative infinity up to your vertex. If it opens upward, that means you start with your vertex and then go up to positive infinity. All right. Any problems? Everybody good? That's straight. All right. So that's it for 3-1. Let's see. So that's it for 3-1. Like I said, we will pull, we'll hold back today as far as doing anything else. I want to give you guys opportunity to knock out, chapter 2 without more stuff being thrown at you. But, of course, we don't have the flexibility to not do anything 2 days in a row, right? So at least want to throw 3-1 in there and get us rolling into chapter 3. So take advantage of the time, get chapter 2 done as soon as possible. Of course, I'm going to give you to the 20th, as your classmate suggested. I have no problem with that. But don't wait till the 20th to get started on chapter 2, because that will put you in a compromising situation. Like Mr. Williams was talking about in one of the office hours, you want to put yourself in a position to be able to walk away from it if, need be, versus just it's the weekend before and now you got to sit there and do everything. And you don't want, to be in that type of situation. So yeah, work on this stuff, gradually knock it out. Because we have to keep going, we have to keep moving. Heaven forbid I have a class that we don't move all the way to 9:15. Like I said, it's tough out here in these streets. these mathematical streets. So professorial streets, right? So yeah. So do you have a midterm next week? No midterm. Unless y'all want it. Now, if y'all gonna send me to the principal's office, but because I'll give y'all a midterm, let me know. Y'all know I'm on thin ice. I don't know what to do, what not to do. Uh, but yeah, I didn't think majority of you guys wanted a midterm. So no, we're just gonna keep moving accordingly. You have 2 tests out there now. So if you really want to talk about where you should be, we want to look at let your midterm be, hey, I need to have chapter 1 and chapter 2 stuff done. If you didn't get chapter 1 stuff done, then you need to hit me for an extension so you can get chapter 1 stuff done and not have zeros. So of course, that's an individual thing. Make sure you email me and we'll make that happen, see what we can do. Democracy, no. But yeah. So let's see, anything else before I let you guys go. So chapter 1, chapter 2 stuff is really the main thing on the menu. Make sure after you've done your test, you shoot me a scratch work. And yeah, when we get back, we'll look to knock out chapter 3. We'll keep working on chapter 3. Also, don't forget the 18th, we're having a visitor, having the dean to come through. There's nothing for you guys to do other than be yourselves, but just, letting you know that there's an extra person in the room. That's it. So no cussing. Sometimes those slip out sometimes, so hold those in, at least that day, try to hold those in. Other than that, any questions, concerns, or comments before we close out? Everybody
Did you
good?
get my email with my scratch work
When you send it?
yesterday?
Okay, I haven't answered emails on yesterday. I'm backed up on email, so I'll get that today. And you should be good to go. All right, so it's Vogel. So if you guys are good, I'm good. Have a great weekend. Be safe, and I will see you on Monday.
Yeah,
All right.
Monday.
Take care. Thanks.
Good day, sir.
Sir.
Thank you. See you Monday.
Thanks. Take care.
See ya. Wouldn't want to be ya.
Thanks.
All right, I'll check you out this afternoon.
All
I'm
right.
rest out because I don't have a class right after this today. So
Okay.
I got an opportunity to knock some stuff out. So I got some questions this afternoon if you're still around.
Okay. Sounds good.
All right, man. I'll see you then. Thank you.
Yep. Take care.